Hello everyone and welcome to a new video. My name is Sasha and today we're going to build a programmable motorized camera slider. By the end of this video we will make a simple but also very powerful camera slider that we can easily control and program with our phone, tablet or a PC. We will create a simple web interface that allows us to individually control the camera position, sliding distance, rotation and speed individually. Also, it's going to be very compact, so it's easy to carry around or mount on a tripod. So, let's get started! So, you might be aware that there are many different types of camera sliders with different features, different applications, form factors, and obviously price tags. So, before we begin, let's jump in Fusion 360 and show roughly what are we going to be building today. From a very high level, here are the main components of our motorized camera slider. I'm calling this part the main platform. It houses our stepper motor and also the rotating platform. On top of the rotating platform, we can mount a camera or a phone to take videos and photos. Then we can use a stepper motor to rotate everything around its axis. Our main platform also needs to be able to slide from side to side. So first we need something to slide along. For this, we will use a 2020 aluminum extrusion, which will also serve as the main body of our camera slider. Then we will also add 4 wheels to the main platform to allow it to glide along the aluminum extrusion. Finally, we will add another stepper motor, idler and GT2 timing belt that also attaches to our main platform and allows our stepper motor to move the main platform left and right. This is a very simple setup, but it gives us a lot of freedom and flexibility to create amazing video shots or time lapses. As always, this entire project is open source, open hardware, so we will stick to off-the-shelf components wherever possible, or at least list the off-the-shelf alternatives that you could use. Now that we know what we are building, let's take a look at all the parts we are going to be using. We are going to use 2 stepper motors, one to slide the camera from left to right, and second to rotate our camera around. In order to control them, we will need 2 stepper motor drivers. I'm going to use these TMC stepper drivers, but I have also listed a couple of alternative off-the-shelf modules you could use for this purpose. We also need to know the position of our sliding platform, and for that we will use a simple limit switch. We will explain how it works later in the video. We also want to be able to power our camera from a wide range of battery sources and power supplies, so we are going to use this off-the-shelf DC-DC voltage regulator to allow our camera to be powered anywhere from 12 volts to 48 volts and step down that voltage to what our camera slider actually needs. Now, for the brains of our camera slider, we will use ESP32 because it's easy to source, and thanks to Arduino and Conformio, the code is easy to use, understand and modify by anyone. Also, we will use ESP32 because it allows us to create a simple web interface through which we can use and control our camera slider. For the main body or the frame of our camera slider, we will use a 2020 aluminum extrusion. It is inexpensive, super easy to source, and also you can get it in any length you need. So if you decide that you need a longer or shorter camera slider, you would just change the length of the aluminum extrusion and everything else remains the same. Also, it's going to make our camera slider very sturdy while keeping it very light for carrying around or mounting on a tripod. We will use 4 V-shaped sliding wheels to attach our camera platform and allow it to slide along the aluminum extrusion. Then we will need 1 closed-loop timing belt that will rotate our camera around its axis. And also we will need another piece of timing belt that we will cut to size based on our 2020 aluminum extrusion length. This will allow us to slide our camera from one side to another. We will also need a few additional components like pulleys, idlers, couple of bearings to allow the platform to rotate freely, and a screw to act as a camera mount. Also, we will need a handful of screws and bolts, and we should be good to go. I am going to use a 3D printer to print the camera platform as well as the mounts for the motors. However, these parts are super simple and you could make them from any other material that you are comfortable with cutting and drilling. For the camera platform, you could 3D print it like I did, or get one of these gantries for the 2020 aluminum extrusion and mount your camera to that. Now it's time to put it all together. Same as with all my other projects, this one is also open source open hardware, so you are welcome to take a look at the source code and see how it works. But this video would be too long if we did a deep dive on every single piece of the camera slider and how it works, so we will keep the firmware and software part of it at a very high level. But if you have any questions or would like to see a more detailed video of any part of the project, let me know down in the comment section. Now that we have everything assembled and programmed, we will control our camera slider through the built-in web interface. We can access it via web browser on our phone, tablet or a PC. When we first power up the camera slider, the sliding platform can be anywhere. So we need to home it first in order to have camera slider know exactly where the platform is. This is where our end switch comes into play. Basically, we are telling the camera platform to move backwards until it hits the end switch. When this happens, we know exactly where our platform is. Here we have a manual control of the camera. Basically, we can tell the camera slider to which position to move to by specifying distance for sliding platform and rotation for rotating platform. We can control our camera slider simply by giving it 3 parameters, which are start position, end position, and duration of the transition. To better understand this, let's see that in action. First, we manually move our camera slider into a position from which we want to start our camera move and click on Set as Start Position. This tells the camera slider to use this position and camera rotation as the desired start position. Then, again, we move the camera to a position where we want to end our camera move and click on Set as End Position. This again tells our camera slider to remember this as the end position of our camera move. Third parameter is where we tell the camera slider how much time should the transition or the move from the starting to the end position take. And then finally we click Move. The camera slider will move from the start position and rotation that we set towards the end position and rotation that we set. It will calculate all the necessary moves and steps that are needed to have a smooth motion between these 2 points and to spend exactly the desired amount of time moving from one point to another. We have also added 2 helper buttons, Move to Start and Move to End. When we click on them, they will move the camera to its start or end position respectively. These can come in handy to examine our start and stop position or to make changes to them. We also have buttons to enable or disable stepper motors and also a camera slider status section. The status section tells us the current state of the camera slider and the programmed start and end position that we have. We also have a settings page that we can use to configure many different parameters, like change the length of our sliding rail, various speed and acceleration parameters, and so on. Also, we can individually invert homing, sliding, or rotation direction, which can come in handy if you have a different motor wiring or you are not sure what it is. And with all that complete, we have a very compact but powerful camera slider that we can use to make all kinds of cool videos and time lapses. It allows us to have a very precise and repeatable camera movement while still being very easy to use via phone, tablet or PC. I hope you enjoyed watching this video as much as I did making this project. If you did, please hit that like button and maybe consider subscribing to my channel. And if you have reached this part of the video, thank you, you're amazing. That's all for today's video. Thank you all for watching. My name is Sasha and I'll see you in the next video. Bye!